There we go. Okay, here's the formula. So sensitivity, and these are under the 5.4 section. I did add them in. But I did put the definition after. I haven't captured everything. Why did it do that? There we go. I don't know what happened. Maybe because I had it open for a while. I don't know. Can you see the screen marked section 5.4? Yeah, it says
Yeah.
Okay, I don't know. Don't know why it shut off, but anyways. Feels like Monday. We are recording, right? Yeah, I reset it. So for sensitivity, it gives you the formula here. But it's also the probability you test positive given you have it. What the test tells you is it correctly tests a person who has whatever it is we're talking about, in this case, age. Specificity says the ability of a test to correctly test a person who doesn't have it. And that's these people. They don't have it, and it told the test was negative that they didn't have it. S divided by Q plus S. Test negative given you don't have it, which is a good thing. So if we look at this problem we did last class. To find sensitivity, it's positive given you have cancer. Because we have cancer, we're only using this column. Positive is the 72 out of 80, which is 90%. So the sensitivity of the test is 90%. The other one, specificity, is the probability you test negative given you don't have cancer. If we use the given part, that gives you a row or a column. In this case, it gives us a column. This column is not having cancer. Testing negative would be this one. Nine, 2, 2, 6 out of the total. So its specificity is 93%. (93% of the time, if you do not have cancer, it will tell you you don't. Any questions on that? We'll do it again with the other, because we did 2 of them last class. We talked about the water that was contaminated. Any questions on the last one, though? Okay, let's try the same thing. Find the sensitivity.
Do we have to put it as a percentage, or can we leave it as a fraction?
For sensitivity and specificity, you should put it as a percent.
Okay.
Any other probabilities I would ask you, unless it specifies, a fraction is fine. But for rates and these two, you do want to have the percent. Positive, given it's contaminated. So contaminated would only use this column. Positive 25, 24 over 40. Getting 60%. And we were given that in the story problem, but for the second one, it's not contaminated is what's given. So we look at only this column. And negative is the 787. Um, 82%. Any questions on that? Was there questions on the attendance? No? I think this all printed. It looks like everything else did, just the top one a little. Is everyone okay with the attendance?
Can you please go over it?
This is a good one to study for the contingency table part of the test. There'll be one where it's already filled in and I'll ask questions, but then there'll be one where you have to fill it in. No, this one, let me bring up the whole thing. Moving so slow. That way we can see the information at the same time. So the strep throat one, you can actually fill out the table without the information, but then some of the parts is you need to understand it. The strep throat test, the thing with strep throat is if it's not taken care of with an antibiotic, it can cause all of these problems. Heart, joint, nervous system, kidney failure. It needs an antibiotic or it can kill you. And that's why if you've ever gone for a strep throat test, they do the quick one in the office, but if it tests negative, they do a longer one, send it out to make sure, because it's important to catch it. Now, of course, they wouldn't do that unless you have 2 of the 3 symptoms: red throat, sore throat, and a temperature. If you have any 2 of them, then they send it out. And so that's why that one was important to see the wording for it. But as we're filling it out, This one's not too bad. We can fill it out with what we're given. For instance, if you have strep throat, out of 100, how many would test negative? What number should be here? Anyone?
10 or 5.
Because we know it needs to add up to 95. So if we subtract the 90, we get 5. How about here? This bottom row. It needs to add up to 100. If this is 95, 100 minus 95 is 5. Any questions on filling out the table? Again, going across, 5 plus something needs to go to 8. 8 minus 5, 3. And if this is 3, and it needs to give us a 5, 5 minus 3 is 2. Add across, 92 plus 8 is 100. Any questions on that part? So once you find some of the values, you can just start filling in the other ones. This case, I set it up. In a contingency table, for the positive and negative rates, this one you have strep throat. Now going across, you're testing positive, so both of these are positive. And both of these are negative. Now it just depends on if it's true or false. If you have strep throat and your test was positive, it was correct. It was true. If you tested positive and you don't have it, it was wrong. It was false. So the positives is your test and the negatives. Then if it's right or wrong is the true or the false. So in this one, you tested negative, but you have strep throat. So the test was wrong, it's false. Here, you test negative and you don't have it, it was correct. So it's a true negative. Those are all important rates. This one here, the true positive, is the sensitivity. And the other one is here, it's a true negative rate. As long as your test is going across, and I will always set up the test going across. That's where these will always fall. So you can memorize, or you can write it for your formula sheet where these are. And that these two are the same if you want. Any questions? We did this in chapter 5. I just forget which section it was. Probably 5, 3, or 4. So if we want to find the true positive rate, that's here. 90, and always use the value below. 90 divided by 95. And you want to write it as a percent because the rates should always be a percent. You could put 95% or 94.7. I didn't specify, so. False positive was this one. 2 divided by 5. As long as it's set up with the test going across, you always divide the total on the bottom. So it was 2 divided by 5. 40%. True negative, it's right here. 3 divided by 5. This is our sensitivity. This is the specificity. That's kind of low. False negative is this one here. 5 divided by 95. Any questions on that? Notice that these two add up to 100. And these two up to 100. Any questions? What percent of patients test negative? So this is all of the patients. It didn't specify anything was given. So it's the total. What percent of patients test negative? So find out how many tested negative, 8, and divide by the 100. Any questions? The next one, given a patient tested negative, what percent have strep throat? So we know they've tested negative. We're only using that row then. So we're just using this row. Patient tested negative. What's the percent that have it? Tested negative but have strep, it would be 5 out of the 8. You can leave it a fraction. If it says sensitivity, specificity, or any of the rate ones, you have to write as a percent. The others, it can be a fraction. Any questions on that? Looking at the false negative rate and the answers from part C, why does the doctor have negative tests tested by the traditional method, which takes 2 to 3 days? False negative, right here. That means you have strep, but it was negative. That's 5.3%. What patients test negative? 8%. So only 8% test negative, and 5% of that have strep throat. So they need to send it out. Remember, they're only doing the test if you have the symptoms, at least 2 of the symptoms. And that's why there's only 5 that didn't have it. But it's important to catch those 5, 1, because you don't want them to pass it to somebody else, and 2, because you can't get rid of it without an antibiotic. And so that's why by sending it away, there's more accurate tests, but it takes longer. And so you just want to explain that. That even though it's 5.3%, those people will infect other people and they could have kidney failure. Any questions on that? The COVID test is similar, especially when it first started out. They said even if you test positive, or I mean, even if you test negative, you could still have COVID. So still wear a mask until your symptoms are gone. Same reasoning. I mean, you don't need an antibiotic for it, but you can pass it on very quickly. And so that's why they have you do that. Now, to fill this one out, we need to use, so you find where these are, and it's the paragraph above it, and then this little part below, right here. So we'll start with the part above it. You could always go back and read. But this part here, starting with however, will help you fill in the sheet. Make it a little bit smaller. Let's say 100 people are experiencing the symptoms, and that's what I put the 100 in there. Of these people, 80 actually have COVID. So out of the 100 people, 80 actually have COVID. Where will we put that?
Under the have COVID total.
Yes, very good. Yep. 80 have COVID. So then out of 100, how many don't have COVID?
20.
Mm-hmm. A positive test means we can be pretty certain someone has COVID. But if the test misses 30% of those 80 people, this means 24 out of the 100 will have a false negative. False negative is here. If you look at your little paper, and says there's 24. It also says it misses 30% of the 80. And if you take 30%, oops, sorry, I didn't mean to click that. 30% of the 80 is 24. So of the 80 people that have COVID, 24 of them test negative. Which means how many test positive and have COVID? Oh, why that square is there? Any questions on that part? So 24 out of 100 people have a false negative test result. Now, if we look further down, right here, based on the assumption, I think there's some, no, that's not. Based on the assumption that swab tests correctly identify 70% of those with COVID. And if you did 70% of 80, you get 56. 7 times 8, 56. 95% of those without COVID. So it correctly identifies 95% of those who do not have COVID. So if we look at the ones that don't have COVID, to be correct, it would be this one because you don't have COVID and you test negative. And that is 95% of the 20. $19. Which leaves, if this has to add to 20, leaves 1. Any questions? So you really only needed that paragraph, but I thought it was good for students to read all the article, or if you were interested, you could go back and read it. Any questions on that part? Just like the last problem, true positive is here, and you divide by the total. And I think it also told us somewhere it was 70%, but 56 divided by 80. And a true positive and a false negative need to add up to 100%. False negative is here. 24 out of 80 is 30%. False positive rate. That's this one. Because they tested positive, but it was wrong. %. And true negative, these two need to add up to 100, so this would be 95%, which it was given. So these 4 need to be written as percents. And this is our sensitivity and test negative. Wait, yeah. Specificity.
What is specificity and sensitivity mean again?
Sensitivity is the probability you test positive given you have it. So if you do have it, it's the probability you will find out from the test, and that's 70%. The other one is the probability you test negative given don't have. So if you don't have, in this case, COVID, what percent will test negative? And that's 30%. This one was So you're seeing how accurate it is depending on whether you do or don't have it. If you have it, you're gonna find out 70% of the time. If you don't have it, you'll find out you don't have it 30% of the time. Wait. False, true, negatives. Nope. No, I got messed up. I wrote them in the wrong order. True negative is here. It's that one. Test negative and you don't have it. That's this one. I had it in the right spot. It's here and here. So this one. Shouldn't be writing the part then. And this one is sensitivity. Negative, and you don't have. Any questions on that? So the specificity is here. 19 divided by the total. Positive, or not positive, sensitivity is here, 56 divided by the total. Any questions on that? What percent of patients test negative? So if we're talking about all of the patients, so you want to be careful. These are givens, and that's why we're only using the values below them. But here, if we're talking about all of the patients, what percent of the patients test negative? Then you want to find the total that are negative divided by the 100 in this case. So we want to add across 657, 2, 3, 43. And it says percent here. Any questions? Given the patient has COVID, what percent tests negative? So given they have COVID, that's this column. Test negative is the 24. %. Given the patient tests negative, then that's where you would only use the row, the negative row. The probability they do have COVID, 24 out of the 43. And it does say percent. I'm just rounding to a whole percent. Any questions on that one? This article states And so you'll want to read the article. The fastest test being used to diagnose people infected with coronavirus appears to be the least accurate test now in common use, according to a new research obtained by NPR. And this was, I think it was 2 years ago now. Write a paragraph, explain why we should use it. Use your false negative rate from the problem above. Also, what can we do to make sure we get those that do test negative, but have the coronavirus? Is there any questions on that, or do you think you can write about it? See, they're using this test. It's not as accurate as other tests, but it's quick, just like the first test you use for strep throat. It's fast, it gets a lot of people, but then there's some that don't get it. And so that's why they should send it out and use a more accurate test on the negative ones. But the fast test was so that you could get it quickly, because if you look at this picture, how fast everything doubles. Now it's changed, COVID strands have changed and they're not as deadly now. But there's still a lot of people with it. So you want to write a paragraph about that. About how the quick test gets a lot of people, so they know right away that they have it and they can quarantine. And then the other ones, they should send out for a more accurate, longer test. Because we're talking about people that have the symptoms, not just anyone who walks off the street. You do have to have certain symptoms. Any questions on it? The last one, pick one of the 5 home tests in the article and explain what the true positive and true negative means. So they're giving you the true positive and true negative. Then find the false positive and false negative and explain what they mean. Lastly, to create a contingency table, what other information would you need? So the first thing you want to be careful of is, remember that I had said these add up to 100. So the true positive and the false negative add up to 100%. And the false positive and the true negative add up to 100%. So you're given 2 of them. You can find the other 2 by subtracting from 100. So there's number 3. Right after number 3, they tell you about different rapid home tests. And they're marked in purple. So Binax now, that was a very common one. You've probably seen that one. They were giving it away free. Q Health's molecular based tests. And each of this will give you the true negative and the true positive. And you just have to pick one of them. So pick any one of them. I like the Binox because that's the one I have at home. The Binox Now test correctly gave a positive result 84.6% of the time, compared to the same study, the test correctly gave a negative result 98.5% of the time. And so the true positive is 84.6 because it correctly gave a positive result. So correctly giving a positive result means they had COVID and it was correct. So the for that one. Now, if you want to do another different one, that's fine. But the true positive $84.6. What does the true positive mean?
That they take the test and it's positive and they actually have COVID.
Mm-hmm. So of those who go in to take the test and have COVID, 84.6% of them will find out by the test. And then the false negative. Oh, I don't want to squeeze that big. The false negative is the 100 minus the 84.6. So of those who test negative, it will be wrong. They will have COVID. 15.4% of those who have COVID will not know. And that's one reason why they say if you have the symptoms, wear the mask. And they should test it away for a longer version. The true negative means you tested negative and it was correct. So if you don't have COVID and you use the test 98.5% of the time, it will tell you you don't have. To find the false positive, you take 100 minus the 98.5. 1.5. So you're testing positive, but you don't have it. So of those who do not have COVID, they will only 1.5% will test positive. So that's pretty good. The biggest thing is this is only 84.6%. And so those other 15.4% that have COVID need to find out they have it. And you can look at the different tests they have here and see which ones are more accurate. This one has a 92%. This one, though, notice it takes 20 minutes, where I think the other ones are 5 minutes. And that's why it's more accurate. But is there any questions on that? If we were going to create a contingency table, and if we have all these percents, what are we missing? Oh, shoot, I didn't realize time went by. The two things we're missing is the total number of people. We would need that. And we would need to know how many have COVID and how many don't. So we need that bottom row totals, or we cannot create the contingency table. Any questions on that?